Hello friends, welcome to alilearn.com. Today we will study surfaces in partial differential equations. आज हम partial differential equations में surfaces पढ़ेंगे and उसके बाद we will find the partial differential equation of two-parameter system of surfaces. Fine? इसके बाद हम two-parameter system of surfaces की partial differential equation calculate करेंगे. So friends, roughly what do you understand by a surface? What is a surface? Surface क्या होता है? Let's see. A surface is a geometrical shape that resembles a deformed plane. So, surface एक geometrical shape होता है which is basically like a deformed plane. What is a deformed plane? Means एक plane एक rectangular plane है आपका. Deforming means उसकी shape change करना. So means suppose आपके पास एक rectangular plane है and उसको आप उसके अगर दोनों ends को आप join कर दो then it takes the shape of a cylinder and that is a surface. So surface is something that resembles a deformed plane. A plane is a surface and whatever structure we make by deforming the plane, जो भी स्ट्रक्चर हमें प्लेन की शेप को चेंज करके मिलता है दैट इज अ सरफेस. फॉर एग्जांपल, द बाउंड्रीज ऑफ थ्री डायमेंशनल ऑब्जेक्ट्स. सो यू मस्ट हैव सीन सिलेंडर्स, कोन्स, स्फीयर्स. ये सब थ्री डायमेंशनल ऑब्जेक्ट्स के जो बाउंड्रीज होती हैं दे आर द मोस्ट फेमिलियर एग्जांपल्स ऑफ surfaces. Okay, so cylinder, as you can see, ये जो सिलेंडर है इसका जो बाउंड्री है that is a surface. ये सिलेंडर itself is a three dimensional object and जो उसका बाउंड्री है that is a surface. You must have seen a cone. A cone is again a three dimensional object लेकिन जो उसका बाउंड्री है only the boundary portion that is a surface. And lastly, sphere. Sphere is again a three-dimensional object, लेकिन जो उसका boundary है, that is a surface. So, ये roughly एक definition था, means just a geometrical definition of what is a surface. In the next content, we will see what is a surface theoretically, but geometrically, just understand that it is a shape that is formed by changing the shape of a plane. Okay, basically it means deforming a plane. एक plane को आप deform करके जो भी object बना सकते हो, that is a surface. So now let's move on to few more concepts regarding surfaces. Surface. So you must have seen curves. Curves क्या होते हैं आपके? Curves are basically the objects that depend on two variables. Okay. And surfaces आपके three variables पे depend करते हैं. तो it's like something extending from curves. Surfaces basically are extension of curves. So it is just an extension of representation of curves. Surfaces basically three dimension में ही हम उसको view करते हैं, like the surface of sphere, the boundary of cylinders, और whatever three dimensional object जो उसकी boundaries होते हैं they are surfaces. And in two dimension only like the plane, the rectangular plane, that is a surface. So surfaces can be in two dimensional space but they are basically planar surfaces, and they are in the three dimensional space. What are like the examples that we saw previously, the boundaries of the three dimensional object. So mostly जो हम रियल लाइफ में सर्फेस देखते हैं दे आर इन थ्री डायमेंशनल स्पेसेस विच आर द बाउंड्रीज ऑफ थ्री डायमेंशनल ऑब्जेक्ट्स. सो दिस वाज अ स्मॉल इंट्रोडक्शन रिगार्डिंग द ज्योमेट्रिकल इंटरप्रिटेशन ऑफ सर्फेसेस. ज्योमेट्रिकली सर्फेसेस क्या होते हैं? दे आर बेसिकली द बाउंड्रीज ऑफ थ्री डायमेंशनल ऑब्जेक्ट एंड वी कैन ऑल्सो कॉल देम एन एक्सटेंशन ऑफ कर्व्स. सो इसके बाद we move on to the theoretical definition of a surface. So as you know कि curve is a function of two variables. Now we will see that a surface is a function of three variables. In a curve, one variable, that is the independent variable, it is free to take any values. In a surface, two variables are free to take any values. So now let's move on. Surface. So a surface is the locus of a point moving in space with 2 degrees of freedom. So as I told you before that in a surface, two variables are free to take any values. Basically, surface is a function of three variables, out of which two act as independent variables and one acts as the dependent variable depending on the two independent variables. So surface क्या है? Surface locus of a point है moving in space with 2 degrees of freedom. By the word locus, you can just understand that it is like equation of a point which is moving in space with 2 degrees of freedom. Fine. So now we will move towards writing equation of a surface. There are two ways of representing surfaces. One is implicit representation and other is explicit representation. हम इन दोनों representations को study करेंगे and let's see what is there in that. So firstly, this is again that there are two ways of representing equation of a surface. So implicit representation and second is explicit representation. So again I repeat, a surface is the locus of a point moving in space in which two variables are free to take any values, and there are two ways of representing equation of a surface. First is implicit representation and second is explicit representation. Now let's see what is implicit representation. So implicit representation of a surface. So initially I said that a surface involves three variables. So what happens in implicit representation? The three variables are connected by a single function. Okay, this is what I mean. The implicit representation of a surface is given by the equation. It consists of all those x, y, z in R cube such that f of x, y, z equals to 0, where f is some function. Okay, so here the three variables x, y, and z, they are related by this single function f. That is called the implicit representation. So basically, the implicit representation of surface means collection of all those points x, y, and z in R cube such that f of x, y, z equals to 0. Such a representation in which all the variables are connected by a single function, this is called implicit representation. Fine. We can also express this one in another way, which is as follows. If the rectangular Cartesian coordinates x, y, z of a point in three-dimensional space are connected by a single relation of the type f of x, y, z equals to 0, then the point x, y, z lies on the surface. Okay, so this was regarding implicit representation of a surface. Again I repeat, implicit representation means all the variables are connected by a single function. Okay, so in implicit representation of a surface, the surface consists of all those points x, y, and z such that f of x, y, z equals 0. And we can also consider it in this way, that a point with rectangular coordinates x, y, and z is said to lie on a surface if they are connected by a single relation of the type f of x, y, z equals 0. Okay friends, so this was regarding implicit representation of a surface, and now we move on to explicit representation of a surface. So now we come to explicit representation of a surface. So friends, suppose if we can express one variable as a function of other two variables, then such a representation is called explicit representation. इन अ सरफेस हमारे पास तीन वेरिएबल्स हैं एंड अगर हम एक वेरिएबल को बाकी दो वेरिएबल्स के फंक्शन की फॉर्म में लिख सकते हैं, देन वी से कि दैट रिप्रेजेंटेशन इज explicit representation of surface. So, explicit representation of a surface is given by the equation S equals all those x, y, z in R cube such that z equals a function of x and y. Now, this is called explicit representation in which one variable can be expressed as a function of two variables. So, in explicit representation of a surface, the surface is collection of all those points in R cube such that one variable is a function of other two variables. So what I said is this thing, that sometimes an equation can be represented in a form such that one of the variables can be expressed in terms of other remaining variables. For example, if we can express z in terms of x and y, okay, or x in terms of z and y, or y in terms of z and x, but in surfaces mostly we will be expressing z in terms of x and y. Whenever हम surface का equation पढ़ेंगे, always हम z को express करेंगे as a function of x and y, and whenever such a thing is possible, it is called an explicit representation of the form z equals f of xy. Fine friends, so this was about explicit representation of a surface. I repeat, explicit representation means expressing one variable as a function of other two variables. In the case of surface, it means collection of all those points x, y and z in R cube such that z is a function of x and y. So this was all about explicit representation. Now we move on to one parameter system of surfaces. Okay, so one parameter means that the equation has one parameter which is again and again changing, so we get a system of equations. So now we'll be studying one parameter system of surfaces. System is coming mainly because the parameters is changing again and again, so we are getting a system of equations, and that is called a one parameter system of surfaces. Okay, so it's here one parameter system of surfaces. A one parameter system of surfaces is represented by the equation of the form f of x, y, z a equals 0. Here x, y and z are the variables and a is the parameter. Fine. So this was our one parameter system of surfaces. A system of surfaces which having one parameter, and this parameter is changing again and again, so we have a system of equations. Let's do an example. For example, this equation of family of surfaces of radius 2 and center on y-axis, that is x square plus y minus a whole square plus z square equals 4. So I'm sure recognize this equation, that this is an equation of a surface whose center is on the y-axis with coordinates 0, a, 0, where a is varying. Okay, so this is a family of surfaces having radius 2 and center on y-axis. So here we have one parameter, that is a. So this is a one parameter system of surfaces. Fine, a one parameter system of surfaces with parameter a. So let's once again recall it. One parameter system of surfaces is a system of equation of surfaces having one parameter. This parameter we are denoting by a. As an example, equation of family of surfaces of radius 2 having centers on y-axis. The centers will be 0, a, 0, where a is the parameter and a is varying again and again. So we are getting a system of surfaces, and since it has only one parameter, it is called a one parameter system of surfaces. So afterwards we will move on to two parameter system of surfaces. So here we have two parameter system of surfaces. Now you can easily think that what could be a two parameter system of surfaces. A system having two parameters. Okay, like in one parameter system of surfaces we had one parameter that was a. Here we will have two parameters and we will denote them by a and b. So let's see the definition. A two-parameter system of surfaces is represented by the equation of the form f of x, y, z, a, b equals 0. Here x, y and z are your variables and a and b are your two parameters. So this is a system of surfaces having two parameters. So again these parameters will keep on varying, so we will be having a system of equations. Okay. So this was our two parameter system of surfaces, a system of surfaces having two parameters a and b. Now let's look at an example of a two parameter system of surfaces. Okay, we will consider a similar example as that of a one parameter system of surfaces. There we considered system of surfaces whose center were lying on y-axis. Okay, so the centers were 0, a, 0. Here, the centers won't be only on y-axis. The centers will be depending on two parameters, and that will be forming a two-parameter system of surfaces. So let's see the example. The equation of family of spheres of radius 2 and with centers of the form a, b, 0. Okay. So this is a family of spheres having radius 2 and centers a, b, 0. So a and b will be the two parameters. So this is the equation. You can easily see that this is the equation of a sphere having radius as 2 and center as a, b, 0. And a and b act as the two parameters. Okay. So this family of spheres of radius 2 and centers of the form a, b, 0 is a two-parameter system of surfaces with parameters a and b. So with this we end with the surfaces section, and now in the coming videos we will be calculating partial differential equation of two-parameter system of surfaces, that is of the expressions like this f of x, y, z, a, b equals 0 इन टाइप के एक्सप्रेशंस की हम पार्शियल डिफरेंशियल इक्वेशन कैलकुलेट करेंगे in our coming videos. So thank you for watching this videos, and for more videos please visit our site www.alilearn.com. Thank you.